Professor Pessina is required, please. Mimmo Pessina. Okay. Please recover our places. We have to start with an interesting afternoon session. And I want to invite to the desk my young colleague and friend, Professor Alessandro Leone. Alessandro is the full professor in Bari University. Very lucky because he lives in a wonderful city, full of sun. Okay. Alessandro, thank you for your help to our meeting, and I leave you the floor. You are welcome again.
Okay, thank you very much, Danilo. Thank you very much all. Thank you very much, Marco Fiala and okay. Thank you very much, Danilo. Thank you very much, Marco, and thank you very much all the meeting. I'm Alessandro Leone of the University of Bari Aldo Moro, and I'm a pleasure for me to be here today with you. I'm honored to chair this session and also to be one of the speakers in this session. The title of the session is Machinery for Olive Growing and Olive Oil Extraction. The aim of this session is to give you an overview on the olive oil supply chain in the world, from the Mediterranean area to all the world, with an overview on different varieties, on an overview on different olive growing systems. And this is the topic of the first speaker, that is Professor Edo Ruggini of the National Academy of Olive and Olive Oil. And next, I give you my talk about the current state of art of the mechanization in the field and in olive oil extraction process, with the enhancement in the field and in the mill. Next, after the coffee break, we have other two speakers, Biagio Di Terlizzi. Thank you very much, Biagio, to be here today with us. Biagio is a director of the CIAM Bari and have extensive experience about the international cooperation program. And Biagio will explain us how the mechanization, the effect of the mechanization for the improving of the developing countries. And the last presentation, the speaker is Pablo Canamasas. Thank you, Pablo, to be here today in presence. Pablo comes from Argentina and is a consultant of one of the largest olive companies in the world. And the topic of Pablo is how is possible today to manage a big olive oil company in a modern and innovative way. Wow, I think that we are ready to start with this speaker, Professor Edo Ruggini, for the first presentation. The title is Global Olive Cultivation Between Tradition and Innovation to Preserve Oil Quantity and Quality in a Changing World.
Thank you.
Edo, a special thank to Professor Ruggini, that was my dean, and also because of you, if I'm a professor. Thank you for being here, but he's the president of the National Academia of Olive. Thank you, Edo, and olive oil.
Good afternoon to everybody. Unfortunately, my voice is very low. Excuse me, but I try to talk in some way. Anyway, thank you very much for the organizer to invite me to talk about this timely topic, global olive cultivation between tradition and innovation to preserve oil quantity and quality in a changing world. When we talk about changing world, we don't talk about climate change, but also policy reforms, technological advances, market and consumer trend. My presentation will examine how global olive cultivation combines tradition and innovation to address challenges, ensuring high yield quality of the oil and the olive tree's multifunctional role. Anyway, in more detail, you can find later on in my slide in YouTube. Olive, originated to modern day Palestine and Lebanon, and was domesticated to the region of Mediterranean basin. At the moment we have two forms, Olia europea sativa and Olia europea sylvestris. Olia europea sativa is the cultivated olive with a large fruits, high oil content, but is susceptible to some disease. Instead, the Olia europea sylvestris you can find only in the bush. It is wild, in the wild, with small drupes and low oil content. About 9% of global production of olive comes from the Mediterranean basin. The other part come from other countries with a climate similar to basin of the Mediterranean. You can find in South America, Africa, in Australia, but only they produce only 5%. In the Mediterranean basin, we identified over 1,500 varieties, but very few of them are cultivated. For example, in Spain, that is the main producer in the world, cultivate only 24 cultivars, and 33 are protected designations of origin only. In Italy, instead, we cultivate more than 100 cultivars, and we produce 50 PDOS, protected designation origin olive oil, and 8 protected geographical indication. The other countries in the Mediterranean basin cultivate only 3 or 4 cultivars, no more. Outside the Mediterranean basin, the major producers are Argentina, China, Iran, and Australia. They use normally advanced agronomic techniques, intensive or super intensive, and the automation ensure high quality of oil production. In addition, new terroir give oil with a unique profile, aromatic profile, particularly when the cultivar are used different than international varieties like Arbequina, Arbosana, and Coronet, widely used for super intensive cultivation. At the moment, we produce about 7 million table and oil fruits variety, olive varieties, and 3.5 million of oil. The world olive fruit at the moment is increasing in the world. That is due to intensive plantation in non-traditional areas, and also by the improved cultivation technique. Instead, in the traditional countries that normally exhibits fluctuating yield over the year, that is due, this phenomenon is due to the climate change, alternative bearing, agriculture management adopted, and the socio-economic condition, and in particular to the lack of new plantation. The oil consumption is increasing in the world, while in the European country is decreasing. The price of the oil is range from 5 to 40 euros. That depends on the characteristic of the oil. In fact, we have several kinds of oil. We call novel oil, sweet oil, typical oil, monovarietal oil. But depends also the cultural factor like history, art, landscape, tradition. Depends also to the productive factors like organic or PDO, PGI. and depends also to official quality parameters and to the donistic factor like flavor, aroma, and so on. Olive is not cultivated only for oil or table olive, but olive is an integral part of our landscape. In fact, the landscape from Assisi to Spoleto pending UNESCO World Heritage status. But olive protects also the territory. Olive is integral part of our history and the culture. Olive is the basis of the diet and the health. Today, olive oil is not considered as a condiment as in the past, but is a real food. It also is important for our economy, although representing only 2% of vegetable fats. At the moment, we have 3 distinct types of olive groves, but all of them need to be improved in terms of climate resilience, innovation, and socio-economic sustainability. So we have a traditional, intensive, and super intensive plantation. Traditional olive cultivation is represented less than 200 plants per hectare, intensive 300 to 1,000 plants per hectare, and super intensive, more than 1,000 plants per hectare. The traditional groves is represented by old plants, large and irregular plantation, normally is located in high yield, sometimes in the mountains, in desertic area, in steep terrains, low productivity, low mechanization. And the quality of the oil is very variable from high to low. Mostly of them require reform pruning to facilitate the transition to mechanization. That normally the mechanization is very low in this kind of orchard. Intensive groves we distinguish in low, medium, and high density. Is characterized by regular planting with a single trunk, achievable with all cultivar, that is very important. The full production is reached 7-10 years after planting. Pruning, harvest, and irrigation are mechanized. And these kind of groves are normally subject to modern practices of cultivation like fertigation, biostimulant, the use of a sensor, and so on. Super intensive, is present a high initial planting cost, formation of a continuous edge like a canopy, early productivity, in fact, started to produce after the second or the third year. Mechanization, harvest, and pruning is okay, and they require large capacity of mills for rapid olive processing. Absolutely require irrigation. Without irrigation, impossible to think about this kind of groves. Start to produce after 2 or 3 years, and require absolutely suitable cultivar. Suitable cultivar, I mean with cultivar with a reduced growth habit, disease resistance, and drought tolerance. Unfortunately, we have a very few cultivar with this characteristic. All of these plantation are affected by negative effect of climate change, particularly in the Mediterranean basin, where the temperature are increasing faster than the other. The temperature, negatively affects olive plant, but also oil. on olive plant, the high temperature is dangerous because the low temperature during winter are not sufficient to satisfying chilling requirement. So the plant in spring doesn't flower. In spring, earlier bud break and flowering are at risk of frost because flowering at some time 15, 10, 20 days before normal date. High temperature, in addition, reduce the fruit set and increase the fruit drop and the leaves. In summer, under high temperature, produce a lot of ozone that induce cellular death. And the early ripening reduce oil content. Sometimes also about more or less 30%. On oil, reduce polyphenol content, increase both acidity and oxidative degradation, alter volatile compounds, and fatty acid composition. So the high temperature is very dangerous for the plant. I'll give you only two examples to demonstrate that when the same cultivars are cultivated in two different areas, hot area and fresh area, in the hot area all the cultivar show low oleic acid. Another demonstration is due to the test of panel test commission that each year receive a sample from oil of several cultivar. In this case, received from Ascolana tenera oil, and in over 20 years they observed a decline of of reduction of oleic acid. But high temperature adversely affect also soil in its structure, chemistry, and microbiology. In another word, promote a rapid decline of organic matter and a loss of soil fertility. Fortunately, we have several strategies to adopt to protect the olive cultivation for both traditional groves and the new groves too. For example, agronomic culture practice, technological innovation solution, genetic and breeding, and policies supporting sustainable income growth, like price premiums, like sustainability credit, like carbon credit, and incentive for low impact producer. And normally, olive to reduce this problem of high temperature, we can use irrigation. Irrigation, scientists observe that is sufficient a partial restoration, only 40, 50, 60% of evapotranspirated water to prevent water stress. Water stress is very dangerous for olive, although is a plant quite resistant to stress. And the microflow irrigation system at the moment is the best, one of the best technique for irrigation. But unfortunately, sometimes, and today Professor Leone is an expert about that, irrigation can increase the incidence of a verticillium dahlia, or increase fruit fly like Bacteria ole, reduce polyphenols content the oil, and sometimes also observe the decrease of oil acidity. Maybe subsurface surface irrigation represents the best option, but at the moment is not adopted too much. Today, oliviculture of precision, una precision agriculture should use sensor technology to optimize input in particular and maximize the efficiency. Efficiency in irrigation, I mean plant nutritional, and in particular to detect early disease. We have at the moment several devices like multispectral drones, you know better than me, thermal drones, laser scanning, world view, georadar, and so on. But high temperature degrade soil, obviously. We should reduce the damage by conservation the soil. How? Not tillage, but by using cover cropping or mulching, permanent grass or temporary forage crop. This fact increase organic matter, prevent erosion, improve soil health, enhance ecological balance like microbes. And today is used normally, now almost all farmers use to chip olive pruning branches because that increase organic matter. And when it's possible to apply mature manure or compost or biochar. The olive require high light through the canopy because high light enhance the oil yield, improve oil quality, reduce disease pressure, and maintain a branch balance. And that can be achieved through rational pruning and training system. We have several training systems like VAS, Globe, Monocone, or other that to intercept a lot of light. Because the olive produced in the shadow, like here, produce less oil and less quality compared to the well-illuminated canopy. But recently has been also shown scientists that proper pruning intensity is very important. We suggest manual pruning every year or mechanical periodically. And they observed that a medium pruning increase relative water content in the leaves, volatile compounds in the oil, and phenolic compounds in the oil, and finally oil yield. So mostly of farmers sometimes adopt different kind of pruning, sometimes very intense, sometimes instead they don't prune. That is not good, is not a rational practice. Farmers use also reflective barrier to prevent the damage of the high temperature. They benefit with spraying kaolin or rock powders. The benefits are many. Normally reduce canopy temperature, decrease water loss through the transpiration, improve photosynthesis under high temperature during midday when the light is very high, that provoke photosynthesis inhibition, and protect from solar stress. Normally increase oil content and also olive yield in the fruit. Particularly effective recently has been so that kaolin reduce olive fly infestation about 10% against 35-40% in this experiment. Another practice could be the combining livestock, and the tree crops to improve sustainability in agriculture. That is funny, but this practice is more important for big or large farmer than the small one. Consists in leaving sheep, poultry, cattle to grazing under the plants, and normally livestock produce better meat, better milk, and better cheese, and at the same time fertilize the orchard, and some of these animal control weed and the pest. Another technique is a complement to improve to the income for the farmer, is a complementary crop like producing asparagus or fodder grass, and recently also the use of photovoltaic. Another practice could be improve organic olive cultivation, because organic cultivation reduces environmental impact and meets growing market demand. In fact, recently people prefer organic olive. It's good, sometimes it's not good, so, but normally, in fact, the organic cultivation increased in the last 10 years about 32%. And finally, regarding policies supporting sustainable income growth, they add value through the carbon credit or olive oil tourism. Carbon credit, olive is the ideal plant for carbon credit because it has a positive sequestration emission compared to the sequestration compared to emission. These two lines. And finally, olive oil tourism. There is another opportunity to increase and improve the income of. And what we can do with a new orchard when we have to plant new plants. Apply correct orchard design overall, selecting plant density based on mechanization that you have in your farm, land slope. You should take in account terrain, water viability, and soil fertility. Align orchard goal with a market demand, oil quality certification. But you choose also high quality of plants, and you should select cultivars with high quality, well adapt the plant in that territory, a preferable local variety to preserve biodiversity. This plant you can find sometimes possible to find in 28 active local and international centers that conserve store about more than 2,000 olive variety. You should choose the best quality of plants. We suggest better if you can find a certified plant. It's easy to recognize them because are marked with a blue label. Certified plants guarantee genetic and sanitary and are virus-free, although virus is not particularly dangerous for the olive. For the technique of propagation, at the moment we suggest when possible, micropropagation, because a micropropagation combines the advantages of a grafting on seedling and with a cutting. Micropropagation, you know, everybody know now, consists in producing in aseptic culture in vitro the shoots, and then you obtain a small cutting explant. You can, in many cultivars now it is possible, you can root these shoots in a greenhouse, and the plantlet, they don't require tutor in the nursery. This is the advantages for the nurseryman. Sorry. In addition, the vitro plants, the plant from a vitro, have a dense root system that tending to go downwards, and another word, as pronounced the gravitropism. And also the canopy is very ordered, is very nice, is very regular. These characteristics are maintained also in the field with a regular plant compared to cutting a normal plant from the cutting, with a nice, very good root system. So micropropagation ensures genetic and sanitary uniformity, large quantity in a short time, give uniform canopy and structure, and the plants reinvigorate in vitro. But this reinvigoration is a positive effect, very positive, because reinvigoration means faster growth. The plant, in fact, doesn't produce the first 2 years, or produce very few in the first 2 years, but at the third year they produce a lot. And another suggestion, we suggested to use biostimulants and bacteria or mycorrhizae. You see, this is an old experiment I did many years ago with a student from Indonesia. They use a mycorrhizae from Indonesia, and in all case, in all cultivar, mycorrhizae plant grew faster than the non-mycorrhized plant. That's control. And for relatively to genetic and the breeding approach, for at the moment, you can use for prompt use, you can use the one of the existing, one or more cultivar of the existing cultivars in the field collection. I said before, we have in the world 28 collection, and you choose among them. That is possible because there you can find, no, it's not very easy, but a plant with different vigor that is useful for super intensive. You can find with high oleic acid cultivar, although plants come from south, from Africa, from Tunisia, with high oleic acid. You can find among them a drought-resistant plant with less low vigor, with high total polyphenol, with high tocopherol, and plant resistant to verticillium diet, and also plant resistant or tolerant to Xylella fastidiosa, you know, because Lecino favolosa and other plants were found in those collections. And this is a new, very new, I never showed before. It is possible to find a cultivar or variety, because it's not cultivated at the moment, resistant, tolerant to olive fly. We select this many years ago, this variety resistant to fly. We observe the very attached over this insect. Probably that is due to pruine, but we are not sure. We attend. And for future use, what you can do? You should produce ex novo multipetrate superior cultivar by using all known technology. I mean traditional breeding combined with biotechnological technique. You can select drought, height, resistant to high temperatures, pest disease, and so on. But it's very difficult with traditional breeding to put together all the characteristics, important characteristics. So, to solve this problem, we have gene therapy. Gene therapies, therapy, you know, by biotechnology, by today the recent technology, you can correct some defects of already important good plants. Biotechnology, you know, is very important, is essential in advancing olive production. We obtain good results in the past, like micropropagation, cryopreservation, gene of oil biosynthesis discovered in olive, and recently also genome sequence. This year the people published about the gene sequences in Lecino, and obtained also some genetically modified plant. We obtain by biotechnology tetraploid plant that doesn't exist in nature. No, impossible to find in nature. We produced by biotechnology many years ago. Tetraploid plant we used to reduce plant growth, and at the same time they produce bigger fruits with high oil content. By GMO, by gene transfer, we obtain in olive rootstock, dwarf rootstock, a rootstock that reduce the size of the scion. And we obtain also plant resistant to drought, tolerant to drought, and also plant resistant, to salt, to sodium chloride. This experiment in vitro show nice growth compared to a control plant. The same for what? It's important olive resistant to salt, important for saline soil or for using saline water for irrigation. This morning you showed a futuristic tractor. Now I show you a futuristic orchard, olive orchard. Our goal was also to cultivate olive in the saline water. But we tried, you see, we obtained some good results, but our dream, I finish, our dreams collapsed when we received the order of our government to destroy the plant, OGM plant, authorized the field in our university. They didn't renew the permission, so we destroyed all the plant, but not all, because some of them we sold to United States, to a company, and they grow there, not in agriculture. They use and send now they are sending at the moment leaves, dried leaves for not olive but kiwi with gin that I showed you before for resistant to salt and to drought that we put in olive. The same gene in kiwi plants are cultivated in greenhouse in the United States. They send to Italy for a clinical trial for in hospital in Genova for people affected by multiple sclerosis. So, what do we expect in the near future? Robotization application for micropropagation and the optimization of somatic embryogenesis in olive cultivars to enhance propagation efficiency and also enable gene transfer or gene modification. In conclusion, what we can say? In a rapidly changing world, we can protect the olive's productivity, quality, and sustainability by pairing innovation, cultivation practice adopted to each territory. So, not one olive orchard, not a single olive growing system, but more than one. And at the end, research is vital and must remain free from ideological constraints, pseudoscience, and unqualified influence so that the olive can reach its full potential. Thank you.
Thank you very much.
Sorry for my voice.
Wow, it's okay. Thank you very much, Professor Ruggini, and thank you very much, Edo, for your complete presentation about the overview in olive growing system in the world. Okay, Danilo.
Now I present my friend Alessandro Leone. The speech is about advanced field and mechanical milling technologies to enhance the olive oil supply chain and sustainability towards artificial intelligence. Really a big topic. Yeah. After the speech, we will have a coffee break, and then there are two speeches. And at the end of the fourth speech of this afternoon, we have the session of question and answer. So please keep your question for afterwards. Thank you. I give you the floor.
Okay, thank you very much, Danilo, and good afternoon another time. Only 1-2 slides to introduce myself. I'm a researcher at the University of Bari, and I work on different focus, university teaching of food processing plants and agriculture mechanics and mechanization, and about research I have different topics, agriculture machinery, food process plant, innovative process for recovery by products and wastewater, the system to reduce the energy and water consumption. I work also on the safety assessment in food and agriculture machines according with the national and the European regulation. And at last we have had a new topic, the integration of machine learning protocols to optimize performance of agriculture machine and above all agro-food processing plants. I work also in international cooperation program with the CM Bari and involving in Egypt, Iraq, Palestine, Pakistan and other countries in the world. The focus is always the same, to improve the level of the mechanization in the field and in olive oil and in the process. You know that Italy is always the country's #2 for olive oil production in the world, with about 300,000 tons of the olive oil product per year. To this reason, the research activity in my department in olive oil supply chain is intensive, and I cover with the mechanical aspects all the aspects from the harvest to the olive oil storage until the bottling. And finally, I take care also my family farm with all the problems following the bacteria Xylella fastidiosa that in 1, 2, 3 weeks dead all the trees. This is the problem. For Apulia region today, I think for Italy, and I hope also for the rest of Europe. In this slide, I want to show you the roadmap of my presentation. The first topic is what is the concept of olive oil quality as perceived by the consumer today. The second topics are the milestones of innovation in olive oil supply chain over the year. And the third topic are the examples of innovation in the field and in the mill. And at the end, the conclusions about the future direction of mechanical innovation in olive oil supply chain. But the first topic, I think, is very important to understand the topic of this session. What is the concept of the olive oil quality as perceived by the consumer? The consumer, I think that today research the olive oil because believe that is a product with high quality. High quality, what means high quality? I think that today we have 4 different levels of the quality in olive oil. First and second levels are, for example, the legal quality and the safety, according with the European regulation. This is the standard olive oil, but around the world, olive oils is valued for its health and sensory benefits. Health and sensory benefits according with these compounds, for example, beta-phytosterol, squalene, tocopheroli, for example, polyphenols, for example, volatile compounds. Around inside the bottle, these compounds are around 1-2%, not more. And all the efforts inside the olive oil supply chain are to improve 1% to 2%. This is the challenge. And when I was young in 1980s and until 1980s, the goal of the technology's innovation was the quantity. Quantity was the verb, quantity was the key words. Until the 1990s, we have changed the paradigm, quality. And all the innovation go in the direction of the quality. But today we have another paradigm, the sustainability. What means sustainability in this supply chain? Sustainability means all. Increase the quality, increase the quantity, decrease the ratio between input-output, reduce the consumption of water, and at the same time reduce the consumption of the electricity. All in the same time, and also to promote a circular olive oil supply chain. I think it's impossible to reach all these topics, but this is the challenge. And a good question, in my opinion, is what are the key steps to reach high quality and sustainability in the same time? The steps are 3. In the field, to produce high quality olives. In the mill, to produce high quality olive oil. And at the end, during the storehouse and until the bottling. But how is the topic of the agriculture engineering today to achieve these topics? The agriculture engineering is an answer in first time to reduce the cost of the crop operation. And in this slide I want to show you a typical cost of the cultivation practice in olive groves. The first cost is the harvesting. Is too high, 42%. Is more 40%. The second is pruning, always over 30%. All the other costs are about 20%. What means this? That if I increase the efficiency of the mechanization for olive harvesting, I have a good results in a business for the farm. To this reason, I want to concentrate a first part of my presentation with a specific focus of the harvesting machine. we need efficient harvest machine, but not only, because if I see the last month before the harvest, the olives change the color and increase the maturity index from green to black. But in the same time, decrease the polyphenolic compounds, decrease the health value, and increase the acidity and the peroxidase value. We have only a right maturity index, for example, about 2 and 3. But how long is this period? Depends on the variety. In some varieties, 1 week, 10 days. 10 days to harvest the best. For this reason, we need not only efficient machine, but also fast machine. Fast machine to according with the different, and Professor Ruggini said before, different system of the olive grow, because we have 2 different possibilities. Low density, medium low density, with a discontinuous productive canopy. And we have another word. For example, these 2 different systems with a continuous productive canopy wall is different the machine, is different approach of the mechanic. But we have answer for all the questions, and I want to show you the machines divided in 4 different levels. The first is easy, handheld machine, like this, simple machine carried out on the side of the operator, and you can see in this short video it is possible to use this machine. You know that the work capacity is too low when we use, for example, this machine with 4, 5 trees harvested per hour. Is too low. Is good, for example, in developing country is a possibility, or for a marginal area. This is another topic. But in the world, the machine most used are the trunk shaker. Trunk shaker is the good solution for all the problems that we can have. Trunk shakers like this. And you can see, for example, that the core of this machine is the head clamp, that by using 2 front arms close around the trunk, and by using a hydraulic engine that turn of about 300-400 revolutions per minute, and by using asymmetric masses, can produce multidirectional vibration. And in this case, you can see in this video, as the operator near the trunk, close the clamp around the trunk and open the vibration. That is in multidirectional way, according with the elasticity of the trunk, with a very good results. By using this technology, is harvested today about the 60% of all the olives in the world. Because if you consider that Spain is the country number 1 with 1 million tons of the olive oil, and in Spain this is the common machine that is used. To this reason, we have a very different typology of the machine. For example, self-propelled harvesting machine like this, with a rover with an engine power of about 100 kilowatt and a big hydraulic system to have this effect. And in this video you can see, for example, in the same field, an automatic interceptor system, by using this automatic system to manage the nets, and in the same time the self-propelled harvesting machine to produce the vibration to fall the olives on the nets. By using this machine, we have a high harvest efficiency, around 90%. This is a good results. 90%, I think, is a good results. And in 5-6 seconds, we have completed the harvest or the shaking phase of each tree. We can have this this same system in most economical machine, for example this, where you can use the same tractor that you can have in your farm by using the shaking system mounted on the front side of the tractor. This is a second opportunity. Or you can use, for example, a trailed shaker. This system, I think, is a good solution, but we need a second operator on the ground. And this is another problem in Italy, because the operators, the cost of the worker is too high, because we need one operator to drive the tractor and one operator to, by using the control joystick, to control the machine on the ground, and this is a problem. In our recent research, we have developed with D'Amico Macchine Agricole a specific arm articulated in this point to increase the agility of the machine and to reduce the movement of the tractor. And in the same time we have measured, for example, the optimal shaking time for each varieties. And in considering our experience, 6-7 seconds is a good shaking time. If you go over, you increase the damage on the tree. About the collection of the olives, we can use different system. The system that you have seen in the video, and you can use, for example, reverse umbrella. And in this slide I can see you a video of the reverse umbrella where the operator go near the tree, close the umbrella around the trunk and open the vibration. With this system we can have a good work capacity, about 25 until 40 trees harvested per hour. I think is a good result, with harvest efficiency of around 90%. But when we change the olive grow systems, we change the machines, as reported by the last speaker. When we have a continuous productive canopy wall, like this, with a section, with a rectangular section of 1 meter, we can use in a good way, for example, the over-the-row machine in 2 different versions, self-propelled and trailed machine. And here in this video you can see both the technologies in the same time. This is the future, I don't know, but this is a good system to reduction the cost, but also with this situation there are other problems. But the work capacity is around 0.5, 0.6 hectares per hour. This is the data, not more. Depends on the amount of olives, but by using this system, it's easy to mechanize also other crop operation in a easy way. For example, the manage of the soil by using interceptor, or the manage of the weed by using other interceptor. All is easy, and is easy in the same time to decrease the cost of the pruning. For example, by using a system like this. For example, by using cut bars or disc saws. And you know that in this way we can have a fully mechanization possibility to organize the work. At the end, but we have also another possibility to produce olives in the world by using always a continuous productive canopy wall, but with traditional variety, with the same traditional variety, change only the plant distance, with a section of 2.5 meters. The problem is the cost of machine, but the machine there is. For example, and I think that Pablo Canamasas in his presentation could explain better this concept, because the investment cost is too high for Europe now, and this machine is not in Europe, it's outside Europe. But by using this big machine with a big investment cost, we can have in the same machine the shaking system in the box, the collect system, the dry cleaning olives system, and a continuous system to discharge the olive in a lateral trailer. And you can see in 1 minute the video, but I think that Pablo after can give us the performance parameters, and I think also the cost, because I don't know if the cost I think is too high. For the medium size, the advancement velocity is 0.3, 0.4 kilometers per hour, but in this case you can use the same varieties, the autochthon varieties, and you can have a modern olive grow. Alternative, with the same olive grow, we can have also this other work site by using 2 parallel harvesting systems. One for collect one side of olives and to shake, and the other side collect the olives and storage in a bins. We can in this way have the same work growing system, but we can decrease the cost of the machines. This is another alternative. Now let's move with in our recent research, where by using image analysis, we have make a good planning of the harvest, because to plan the harvest is another problem, because the typical situation is the mill in the middle, all the field around, but there is not a good plan. In the same days, all harvest and clogging the mill. And this is not a good way, but it's possible to planning the olive harvest. Today it's possible if we know with 1 week before harvest 2 parameters, maturity index and the quantity of olives per hectare. In this way I know that you are the first, you are the second, you are the third. Today we can make this by using visual inspection by a competent agronomist, or as demonstrated in this research by using, for example, cartographer, that is a technology produced in Australia with a partnership with a Green Atlas. This system is equipped with RGB camera, LiDAR, strobe lights, GPS device and other. And by using this system, this is also a first step of this research, the system make 2 frames per second of picture. At the end, we have the composition of our field, and at the end, the software can detect each olives and can produce for you, for example, olive oil production per hectare in a simple map. And you can see, for example, that in the yellow area, the production is low. In the blue area, the production is higher, and you can know the production per hectare, and at the same time, so you can know, for example, the maturity index map. With the same system, the maturity index is perfect. The system works very well. And this is, in this way, we have all to plan in a good way the harvest. In next step, we will use the drone to make the detect of each hectare that now is 15 minutes in 1-2 minutes. Now let's move in the mill, and I want to show you the advancement in olive oil production process. Olive oil production process is constituted of 5 different steps: olive cleaning, olive crushing, olive pest conditioning, and 2 steps in a centrifugal way to separate the pomace and to clarify the olive oil. The first step, olive cleaning. Olive cleaning today is made by using 2 different steps: dry cleaning by using mechanical system, and water cleaning to remove all the dirty from the skin of the olives. And in this video I show you the dry cleaning and the water cleaning in this way. And at the end of the video I show you the typical sorting quality of the olives. But if you see in these olives, there are olives with a different maturity index, olives with different attacks by fly, for example. It's possible to improve the sorting level. Today it's possible, for example, by using optical sorting. With optical sorting, by using RGB camera, near camera, and a pneumatic system to separate each olive, it's possible in 2 seconds to improve the level of the sorting of the olives. And we can divide a second quality between the first quality by using only another machine that is not mechanical also, is mechanical and electronic. And by using this machine, the miller, from the traditional olive quality, you can have first quality to high quality olive oil and second quality of the olives. And this system have also an open software where the miller can check the defect that want to delete from the mass. Now about the crushing. We have worked a lot about the crushing phase. Crushing phase is a typical phase where the olives are transformed in homogeneous olive paste. Today, to make this phase is used in all the world Hammer's crusher. It's a typical crusher constituted of a hammer rotor with 3 or 4 rotors that turn around the grid with the holes at a speed velocity about 3,000 revolutions per minute. And by using this machine, we perform pressure force and friction force. The problem is that the pressure force produce overheating on the olive paste. And by using another, we have tried to using another rotor, for example this knives crusher is a different rotor that we can use this in the same chassis of the hammer crusher, but change the force from the pressure force to the shear force. What change is the same? It's the same about the flow rate is the same. Electric consumer is the same. What change? To test this is necessary to put both systems, to put in an industrial olive extraction plan, and in this way, hammer versus knife. What are the parameters that we can check? Quantitative parameters is the first. Quality parameters is the second. What means about the quantity parameters? No differences between these both systems, and the same legal parameters was detected, but increase the health value of the oil, increase the polyphenols content of about 34%, and increase these parameters when you have green olives or olives with maturity index, for example, 3 or 4. The result is about the same, but in the same time increase the flavor of the olive oil, because increase all these compound, for example, the aldehydes, responsible of the green attribute of the olive oils, and the consumer research this particular concept at the end. Also, by using a different mechanical system, we can have different results for a different market with a different final value of the market. And if you see, for example, this video, one moment, there is a difference about the color of the olive oil. More green, more yellow. Green is better than yellow because in the oxidation step, before is green, after you can have yellow. In this case, this means that there was an oxidation level better when you use the hammer rotors. What about the conditioning phase? Conditioning phase is another particular phase where the olive paste is put in a horizontal tank, where a rotary mixing reel perform 2 different unit operation, mixing and thermal conditioning, by using this machine. And in this slide I want to show you an overview of the different machines. This phase is very important for the process because balance the concept of the quantity and the quality in this phase. But where is the problem? Where is the limitation of this machine? The limitation is in the geometrical characteristic of this machine, because by using this machine, this machine performs very well the mixing of the olive pomace, but that does not perform in the same way the thermal conditioning. This for a different problem, such as low thermal diffusivity of the olive paste, low ratio between exchange to surface compared to the volume of the olive paste inside the system, the falling of the walls, and at the end the poor ability of the reel to change the olive paste near the wall in the middle. The result is that the olive paste around the wall overheating and the other part is cold, and we decrease very well the olive oil quality. What answer for this problem? To delete the machine, to divide the machine. One machine for mixing and one specific heat exchanger for the thermal conditioning. We can increase the value of the final olive oil, improving with this advancement inside the olive oil extraction process by using a simple heat exchanger, but specifically designed for the olive paste. And by using this machine, we can have the same extraction efficiency with or without heat exchanger, but with increase or about 30% the health value of the final olive oil. And I think that this is a good result for all the supply chain. And in this slide I show you some heat exchanger with the best companies that produce in the world. We have tried also other solutions to improve the system by using, for example, ultrasound or by using a vacuum system in the malaxation to increase the time and to increase consequently the olive oil quality. Now, in a few slides, I want to meet with you the problems of the centrifugation phase. By using an industrial horizontal centrifugation phase, we can separate unclarified olive oil and in the same time two-phase pomace, or the pomace, the byproduct. Today, the old mechanical part of the mill is managed from the miller with his experience. And there is not other tools to check or to control. But in this phase, we need two different goals. To have inside the pomace a very low content of the olive oil, and in the same time to have a clarified olive oil phase. Until yesterday, we have not the possibility. Today we have a good sensor that by using NIR system, we have a partnership with FOSS, we have developed this particular sensor in NIR technologies that measure in real time the content of the oil lost in the pomace. In this way, the miller can see on the monitor the oil lost in the pomace and have the possibility to change the parameters, the adjust parameters of the plant, and in the same way to see if the result is good or if the result is not good. And in the same way, we have developed a new sensor to measure the turbidity of the olive oil outside this phase. And by using this system, I can see the right level of the turbidity to avoid the clogging of the vertical separator that is the next step. This machine turns at about 6,500 revolutions per meter, and if the machine is clogging, increase the temperature of all the system and increase the temperature of the chassis, and in the same time the temperature of the final olive oil. And in the last step, we have delayed all the quality of the olive oil, because today there are not much sensors to measure each parameter. Okay, habemus olive oil, finally. This is high quality olive oil. What I think about the future direction of the innovation, I think that in the field, as reported by Edo Ruggini in the last presentation, in the field, I think that the future is to improve the system to collect data by using DSS or by using image analysis or by using other sensor to process the data and finally to make a decision. The future is to be machines without operator until the robot, if is possible. About the mill, what are the improvements? The first step is to make circular and sustainability the mill. And today this is possible. This is possible because by starting from the pomace, it's possible to recover the stone. This is a good by fuel. And in second step, we use the pomace destoned for anaerobic digestion to produce in a good way biogas or electricity. Apulia region, this is the direction. No waste on the field, because this system replaces all. And about the plant, I think that the future will be the total control of the process by using the different sensors that today we have, including the energy meter, to detect the energy consumption of each electric engine. In recent research, we have demonstrated that by using a batch processing, first batch from the second batch, or a continuous process, the energy consumption is half, 50% less when the process is in continuous way. Summarizing with this slide, today we have this situation, mechanical system and a miller with his experience in the middle. But it's possible in the same time to improve and to help the miller by using different sensor that today is a good possibility to help the expertise of the miller. But I think that in the future the situation will be this. I think that by using the different actuators on the plant and by using sensor tools and I hope, machine learning protocols, we can make all the system in automatic way. And also in this way, I think that we can reach high quantity, high quality in the same times, reduce the input, reduce the electricity, and to meet, I hope, all the goals of the sustainability. Thank you very much.
Thank you, Alessandro, for your impressive speech, really, full of a lot of information. And now we know more about olive oil. Just a consideration, we are able to spend 20 or more euros on a bottle of wine that lasts only for a dinner. And we have problem to spend 2 or 3 more euros for a bottle of olive oil that is a wonderful food. A wonderful food. For me, olive oil is a food. Thank you. Now we have, thank you again. Okay.
Next speaker.
Yes, now we have the coffee break. Okay, but very, very fast because we have to return as fast as possible to the next 2 speakers. Keep the question for afterwards.
1 minute.
Thank you.
59, 58, 57.
If this is mechanized in the way what you showed, the price should go down.
Yeah.
Because the medium quality, 15 euros.
Yeah, 50 euros is a good price for the local farmer. 50 euros is low, medium quality.
Yeah.
High quality, 20.
20. Which is the best?
Here the production cost of a bottle of 1 liter of high quality olive oil is around €9, not less, in Apulia region.
Yeah.
I will make a comment in Italian. No, no, vai. Hai rovinato completamente l'atmosfera bucolica del
Sì, lo so, veramente complimenti, grazie. Scusate per il mio inglese che non è in fase di miglioramento. Fatto molto bene, lo so.
passavano
La visione
alla canapa.
Anche quella è esattamente come io ho sempre inteso le relazioni introduttive, cioè facevano un quadro generale.
Diciamo che abbiamo lavorato parecchio con Danilo proprio per cercare di partire bene con una panoramica e poi cercare di dare le giuste punture al concetto.
Sei riuscito a non farmi dormire dopo pranzo.
Non è stato facile.
È difficile.
Io l'ho guardata più volte, quindi la monitoravo. Ti ho guardato più volte, quindi ti ho monitorato.
Quando stai per dormire fanno allora no, e tu mi svegliavi.
Ho sempre delle clausole un po', anche se questo è improvvisato. Però io voglio vino me ne sono occupato in passato, per cui poi ci sono più.
Bologna era una grandissima scuola e poi ci ha messo lezioni. Ti posso dire che non solo i tuoi maestri, poi ci ha messo la scuola di Bologna, la scuola del prof Mirante.
Molte cose derivano sicuramente dalla scuola del professor Mira che ci ha indirizzato in una certa maniera. Poi molte cose le provo direttamente da me e le provo sulla mia pelle con i costi di investimento perché c'è un'azienda di 35
Non
ettari.
andiamo super al maestro.
Introduco un attimo Michele Stillavati che è l'ingegnere e direttore generale della Menduni con cui noi collaboriamo, lui ci ha finanziato anche un dottorato quindi siamo
E continui a finanziare
continui a finanziare il
Lei
dottorato.
deve continuare a finanziare il
Loro
dottorato.
sono
Io dell'Università della Tuscia.
Io del retirement, quindi in pensione, pensionato.
ma tanto sono insetti.
Lo so,
Discorso lo conosco.
per cui ecco, sull'olio anche noi ci abbiamo qualcosa da dire.
Giustamente quello che volevamo. Avevo più o meno capito. Ora facci vedere come funziona un'azienda seria del mondo, perché qua noi ci giriamo e ci giriamo, ma andiamo tutti con 10 ettari, 5 ettari.
Arriva Pablo, ciao.
Arrivava con i suoi 6.000
6.000 e Pablo, no, così non si fa.
loro girano con l'elicottero, almeno quello che io faccio il fine settimana, cioè fare un giro nei terreni, e loro lo fanno con l'elicottero perché chiaramente
Ma non è tutto perfetto.
Devo fare i
non è tutto-
complimenti.
Anche noi abbiamo un problema.
per la cravatta, diciamocelo francamente.
Anzi,
Dopo i 15 minuti cala la
Lo so.
è la parte.
Avevamo 30 minuti, li abbiamo sfruttati al massimo.
Abbastanza punti che
sei stato seguito dalla prima parola.
No, ma tu eri occupato, ma io guardavo le persone.
No, ma guardavo anch'io.
Bravissimo.
Hai fatto un argentino lo stesso?
Ce l'abbiamo.
no, un po' diversa, sì, no.
Il professor Ruggini è il nostro faro anche all'Accademia Nazionale dell'Oliva e
Sono
dell'Olio.
approcci diversi, posso dirlo, insomma, ecco. Lui ha un approccio
Ciao, Simone.
ingegneristico, la meccanica agraria, l'altro è un approccio agronomico e l'ingegneria agraria è un'altra roba, però diciamocelo chiaro perché sennò...
Comunque credo che
Nel mondo gli agronomi, solo in Italia chiamano agronomi, nel mondo sono ingegneri.
studiano tutto.
Pablo è ingegnere agronomo, Leandro è ingegnere agronomo.
Con me lo sfonda una porta aperta, sto signore.
sì, lui tra l'altro è l'ingegnere che fa parte chiaramente del settore che si bilancia fra agronomi e ingegneri.
Lo dico sempre, io ci ho messo 5 anni per diventare ingegnere e altri 40 per diventare ingegnere agrario. E continuo ancora a
Mi
imparare.
permetti di dire che io sono ingegnere meccanico del Torino Politecnico di
E
Torino.
tu? No, Sapienza Roma?
No, Politecnico di Torino.
Sapienza Roma è meglio.
Meccanico.
Sapienza è
No,
meglio.
però adesso sono più agronomo che
Io pure uguale.
sono più agronomo che ingegnere.
Ma perché alla fine o ci si avvicina verso
più agronomo
i sistemi vegetali oppure non ci si capisce
Devo
niente.
dire
40 anni di
che
esperienza.
nel nostro settore succede invece il contrario di quello che abbiamo fatto noi nella nostra vita. Loro nascono con un imprinting agronomico classico, poi si appassionano alla materia di ingegneria e diventano ingegneri. Quindi
Abbiamo ripercorso il fiume al contrario, cosa che è molto complicata per gli agronomi, sinceramente.
È più facile, quello che abbiamo fatto noi.
Lo so.
non lo so, sai, però dai un mix. Alla fine io credo che è nella collaborazione, perché certe soluzioni...
Sì, è nella collaborazione,
Noi
quello è fondamentale.
ci mettiamo a disposizione. Io personalmente...
Infatti loro sono per noi dei partner, oltre che degli amici, sono dei partner
Continui a
fondamentali.
finanziare borse di dottorato a sto ragazzo.
Ma sinceramente se lo merita.
Altro che...
Allora, io con 70 anni, quindi diciamo, dopo 70 anni uno non ha appelli
70?
70.
Quindi del 55?
Non ha appelli sulla lingua.
Beh, sono del 57. non è che
Michele,
c'è
tu
una
li
differenza.
avevi 10 anni fa i peli sulla lingua.
Io viaggio.
Come vedi il gruppo che abbiamo creato.
C'è un traduttore istantaneo, cioè cominciate.
Vedi un po',
Dobbiamo fare una foto. Facciamoci questa foto, poi non me la chiedete, non
questo
me
è
la
il giorno dello scherzo di Alessandro
Non me
che
la
mi ha
darò
fatto là per sta cosa
la
qua.
voglio, Alessandro, la voglio.
nel laboratorio.
L'avvocato, eccolo qua.
Lui è il difensore.
Sta venendo dove che ci dobbiamo vedere?
L'avvocato sarà un
Dell'olio
futuro per la
esce dalle macchine.
Noi ci stiamo lavorando.
Grazie alla sua presenza per essere qui per noi.
No, professore, sono completamente discorso. Dopo 70 anni, però non avevo neanche quando avevo 40.
Diciamocelo tutti.
Io non vado d'accordo con l'università, l'eccezione non si può fare. Oggi ti pago io, ti pago bene A, domani mattina mi paga C.
Non è il nostro costume.
L'ha sempre detto.
No, non è il nostro costume. Non l'ha mai fatto, non l'ha mai fatto.
No, ma io non è che vado, io te lo dico in faccia.
Non è il nostro costume.
Io te lo dico in faccia.
Quindi Michele, l'importante non ce lo dice a noi, siamo tranquilli.
Anche il contrario.
Ma vado pesante.
Anche il contrario. Non è perché mi paghi che devo dire il falso. Io non dirò mai il falso. Piuttosto sto zitto.
Invece ci sono dei vostri colleghi
Grazie.
A dire la verità ero incasinato a fare altre cose e avevo un orecchio, ero multitasking, capito? Però no, è un casino anche, c'è sempre qualche ma anche il
Devi pensare tutto, anche perché qui insomma il fatto di persone che si impegnano quindi presidente, il segretario, i sono
no, se non ti trovi in sintonia è meglio smettere.
guadagnare la stima delle aziende locali non è complicato, la stima delle aziende in generale.
Beh, questo in
Che
generale.
ritorna, funziona sempre.
Michele Stilavati, ti piace?
Dell'ingegnere Stilavati è un po' più complesso.
No, io sono
Un po' più complesso.
perché quando vai con le mani belle pulite, sempre chiaro, puoi parlare.
Noi ce le sporchiamo.
No, voi
andiamo.
no, perché infatti le porte a voi sono apertissime.
Bene, allora queste sono altre 2 borse di dottorato per il prossimo ciclo.
È andata bene,
Dai,
io l'ho pensata la cosa.
se ne continua passo a 3.
La borsa di dottorato,
Allora, 2 borse di dottorato.
la borsa di
3.
dottorato che ho
L'avete promesso?
adesso mi ha detto, hai qualcuno da... No,
Fai tu.
Quello è un altro... No, ma
È vero?
che l'ha chiesto anche per un'altra ragione. Effettivamente noi abbiamo dei problemi a trovare dei candidati validi perché molti dei nostri studenti, allora gli ingegneri ci vengono e se ci vengono dopo un anno se ne vanno via.
Gli agronomi
Dopo un
ancora
anno-
peggio.
Gli agronomi sono su queste tematiche nostre profondamente ignoranti perché hanno una formazione molto biologica, molto botanica e poco tecnica tecnologica. Noi ci abbiamo problemi a trovare dei bravi dottorati. Veramente. E se te lo troviamo lo teniamo stretto.
veramente, quando vengono in azienda non li facciamo vedere proprio tutto.
Beh, va bene. Il buon
Proprio
30%.
No, 70.
Alla fine ho
Proprio
chiuso
tutto.
facendo una considerazione sull'olio, riguardo il prestito dell'olio. Ma perché se ti chiedono 20 euro una bottiglia di vino la paghi, anzi ti sembra pure poco?
Perché la bottiglia di vino è bevi metà, l'olio ne consumi 2 gocce, non apprezzi le differenze e quindi per te è tutto
Ma
uguale.
non è
Questo
così,
il
a voglia, se l'olio di canino che è il meglio del mondo, meglio di quello pugliese.
segreto. Ma l'olio di canino, hanno diversi impianti in due.
Lo so. Ah, io lo adoro l'olio di canino, però mi piace anche il blend, una cosa mista.
Non so fare. No, vengono.
Se questo è il compravendita,
Va bene, ma
quale migliore
Si
occasione?
sta camminando, cioè, avvocato, però non possiamo, non possiamo dire tutto.
Una parola in ogni telefonata,
Non possiamo dire tutto, no, non possiamo dire tutto.
ti tiro le parole.
Allora, sta Messico, Colombia, Perù,
Gli avvocati.
avvocato,
l'avvocato.
Tutto il tropico.
È un buon
e poi Kenya, Uganda, Burundi, Ruanda,
dicevo prima, che tu
Etiopia.
te lo giochi come da tavola e se ti va male lo fai ad olio e non perdi mai. Prendiamo un caffè, prendete un caffè. Prendiamo un caffè allora.
Veramente, continui a fare l'imprenditore
Imprenditore con la...
appassionato, l'imprenditore appassionato, perché la
Io
passione
appartengo a una famiglia dove il nostro stava facendo molto 104 anni,
hai capito?
sempre
E guarda,
c'è il futuro.
ti passo subito a tu perché ho fatto guarda, io ti auguro di vivere 140 anni in salute con l'olio. Non ce l'ho, però è semplicissimo. Il monarca, trovi il
Si ricorda
mondo,
facile,
trovi il mondo,
si ricorda facile.
trovi la mia mail,
Poi
trovi
attraverso
e queste ora io Alessandro e lui abbiamo fatto un investimento, abbiamo montato qualche tempo fa su un giovane, perché è giovane Alessandro rispetto a noi, 55 che sta 47 io, a lui un figlio, quando diceva quando ero giovane gli avrei dato se mi sarei stato gli avrei dato una botta, quando ero giovane ha detto, ma che te posso
investimento, andare a vedere cosa fanno gli ultimi arrivati.
lo vediamo, perché magari fanno meglio di noi.
Non magari.
Sì, io ti lascio perché
Va bene, allora adesso cercherò in 10 minuti perché io non ho la vostra eloquenza. prendo le carte.
Please, recover our places, please. We have other two important important speeches, sorry. We have to finish this session with Professor Biagio Terlizzi and Professor Pablo Canamasas, but I leave the floor to Alessandro. Compliments again for your presentation, Alessandro. I leave you the floor, please.
Okay, take your seat, please. We can start with next presentation. Few seconds and after I can introduce the next speaker. One moment, Professor, one moment. Next speaker is Biagio di Terlizzi of the CM Bari, and the title of his presentation is Technologies and Mechanization to Enhance Value Chain in Developing Countries. Biagio, when you want, you can introduce yourself and after you can explain your speech.
Ok.
Bene, good afternoon. I'm quite surprised to be here and realize how really, so much knowledge are here, and my job is something different. And really, at the beginning of my career at the University of Bari was as a virologist. That means that I have nothing to do on what you are dealing, because I was just taking care about the quarantine disease, but quarantine disease not for all crops, just for stone fruit, and not for all stone fruit, just for apricot, and not for the old virus of apricot, just for one virus of apricot, and not just for it, just for the strain of it, but not the mild one, just the severe one. This is me, that's me up to 2000. Then, on 2000, in my organization, which is Mediterranean Agronomic Institute, that belongs to the intergovernmental organization made by 13 different countries surrounding the Mediterranean, the director asked me, say, instead to make just a research network among scientists, why you don't try to make a partnership for cooperation? Let's build cooperation area at the Institute. And this is, now I'm an operator, I don't want to say an expert, but someone that is try to identify problems in the area in certain countries and see how solution can be proposed, and looking first to the solutions that are already in their areas. This is how we do as the Institute. I don't know if there is the possibility to move. Okay, yes, I will do like this. Now are just 2 months that I'm acting as a director of an institution where I start my activity on 86. You can understand, I'm more or less ready to be retired. But before to be retired, perhaps I can be useful for a certain area. This is the institute, I say, is in Bari. It's the Italian seat, as I say, of this intergovernmental organization. We have also other institutes in France, in Saragossa, in Greece. The mandate is to train people for third country. We are dealing on agriculture, we deal on economy, we deal for local development. But it's kind of joke for Alessandra, because he said, okay, let's come to talk. He invited me more than 6 months ago, and then came Professor Mazzetto, say, okay, Biagio, perhaps you can come over there. I say, okay, but today I really realized that I'm not doing your job. I'm doing something else. I'm just, making activity in third countries. And perhaps at the end there will be some things that can link with you. And I will leave you to check if really is fitting with the club of Bologna. And thank you to all of you to let me to talk to this club. And perhaps I already with the two, the two speakers, I already learned some things, or at least I try to learn. We are in Bari, but we are also located in Tricase Porto, which is a location just at the end, the hill of Italy, where we deal on blue economy, something else, nothing to do with the mechanization, Alessandro, still this. But what we do, just we do education, we do training. It's a campus with 10 hectares, where more or less there are 150 people that are making their studies as a master, and then other, colleagues and experts, they are coming along the years. And we use the training in order to make ambassador in several countries. And you will see the country where we will orient our training. And to do what? To do exactly partnership, research in partnership with their university. And with this, it means that the training, the research, and activity of cooperation are the one that could close the circle. And the development of cooperation is the one that we deal, because our goal is how to make their life better, how to let the farmers over there to have a better income. And the mast itself is useful. The TVET, the vocational technical training, is useful too for technicians. And then advanced course, more dedicated to decision maker, is also necessary. And have open innovation activity for farmers or for entrepreneurs is useful too. Now, the student, the technicians, the decision maker, the operation, this is our team. This is our team. In each country we have this. And are them interested, they are interested to deal with an Italian institute, to deal with the expert or the community where they had the opportunity to spend some time. More than 100 countries are already, this profile of ambassador, thousands of people, but this is what I would like to say. 3.92 has social input. This is what we are assessing of our training. We are looking and checking along their career how the steps that he made in Bari has been successful to improve their standard life. And this is why we continue, despite the competition that there is to make courses. This is the number that led us to be in Bari competitive, and we can even extending it. But we do with whom? Research, we say we do with this network. This is why I accept Alessandro to come 6 months ago when you say it, because we had no contact with the Club of Bologna. And we think that among the networks that are working with us, we would like also to check who could be linked with us. We cannot do things alone. We cannot improve. We cannot do another step. We cannot win any kind of competition if we work just alone. And this is, in my mandate, I say more and more network. No activity will be done alone by the institute. But also, this is some things very easy to see, the different area, how we aggregate, because the idea is how to better compete from Bari. No important. We are from Bari. We are not in Rome, where there is all the UN agency. We are in Bari. And we are more stronger in Bari because we have the possibility to deal with the field, with the farmers. And this is our goal. And we reorganize also the research, but now this is where we are. We are in 40 countries present. They are colleagues over there. They are a cooperation unit. And recently we also extended to the Far East for programs that are dealing on resources that are sharing, opportunity, and also in El Salvador, in Central America. But why there is this approach? Our approach is, we say that we have the ambassadors. The ambassadors are dealing and are working their administration, and our interest is to strengthen the administration. We do activity of institutional building, And then institutional building means capacity building, and then we go to implementing it to the field. And this is how has demanded the Institute to do cooperation. And then later, now you just enter, say why I'm here, and the precision agriculture Mediterranean region. There also Professor Mazzetto is one of the experts that opened this course. It's a course that this year was open to 16 different countries. Has a scholarship which are offered by the Minister of Foreign Affairs, and it is is a course for 10 weeks to decision makers. 10 weeks, because we would like to have the person, really the high decision maker, that they could come to Italy and could understand, could visit companies, and they could be back and feel contaminated of some things that they learn in Italy. Positive contamination, not like Xylella, of course. Now, but several programs are involving us regarding mechanization. Yesterday and the day before, I was here with the friends of Federico Nacoma and Maria Teresa Maschio and Fabio Ricci, with the Minister of Congo, with the Minister of Senegal, with the Minister of Ghana. Today I was with the Minister of Bosnia and Montenegro. And yesterday in Rome with the IFAD, we were talking because they say, we saw in Bari what really we need for our development. We needed the mechanization that was shown in Bari. This is what they say. And then when I took the floor, I say, okay, this is what they, but what we have to do as an international organization is that we have to let the farmers to buy. The farmers in this country, they are not able to buy. They cannot buy a single machine. That means that we have to organize the production in order that they can really use the machinery, not just for themselves, but for the group of farmers. Alessandro, Professor Ruggini, you was really speaking for some things very advanced, but the country where I'm usually go and visiting and discussing, really they are looking for their food security. And also olive, it is considered food security. There are country like Pakistan, where Alessandro, you are in the coming days over there, is a country that is covered by olives. Olives, which is not Olea Europea Sativa. But what they ask, they say, we are interested to do not import anymore palm oil. What means palm oil? This has been the question for the government. Say, we don't want to import anymore palm oil because for our GDP, because it's exporting, and second for the health condition, but we want to produce oil. We have this panorama, which is mountains, which is just mountains over there. Even cemetery are covered with olives over there. I said, we want to see if we can graft, if we can produce oil over there, because we need to let people to stay in their mountains. If they will not have any more palm oil, means that they can leave their mountains and then they go to migrate. How we can let be over there and have an oil which they need for their daily diet? And this is what we do as a cooperation. Just working with the people, try to bring really slowly, how they say in Arabic, shue, the possible, say, indication how the people can accept a central decision, but let them to say that the central decision is something for their life, for their family, that is taking care for their responsibility. And this is what we had in Pakistan, dealing on oil. I start with this because the Ruggini and the Leone, they were talking about olive. And this is where our technology should enter. And we can be proud. They will be really open to the Italian technology. They will be open. But we have been also involved in Egypt. What has been the demand of the Egyptian? Say, we have plenty of money, we need machinery. And I say, okay, Alessandro was also involved. Then we make a tender, we select company, but no one tractor could be used in Egypt because the gasoline is not useful for machinery that has a catalyst. And then what we did, we make another tender and to say to the company, please sell us machinery without catalyst, otherwise cannot be used. The good, say, gasoline exists, but just for military machinery, not for agriculture. And it has been also a way, not the demand of government, say, we need that the people, the farmers, can maintain the machinery by themselves. The problem is that the government is the one that buy machinery for the farmers. They don't buy spare parts. They don't buy spare parts. It's much more easy to get funds from abroad to buy another machinery to be cannibalized. It's much more efficient to do this. And then you have really plenty of, say, technological part of machinery that has only the pneu, and then nothing else. This is a kind of Egypt, and that's the cooperation. How to let the government to change their mentality. They want to work with the farmers, but then if you don't change, if you don't let the farmers to have their money in renting the machinery, they can never maintain. And you have to let the law to be changed that someone else organized in group, association, or cooperative can be able to access directly to the market. And just to enter in this is our problem. But then there is, we can mention about Kurdistan, just to stay about olives. Kurdistan, for years, has been made a greening plan in Kurdistan. The Iraq, Kurdistan. I will leave. And they say, okay, now we have plenty of olives, but how to make the olives productive? And this again, the experts, they help us to change some things that just for greening the country to have our plenty. We can talk about south of Libya. We can really talk plenty of country. But I would like to say just one word about this project. This tandem Italian and Tunisia. This is the biggest project that Italy has never made. Biggest. Is something that is involved is to have, sewage water treated and transferred to the desertified area, not just recently desertified, but desertified from tens and tens and tens years. It's a project that intends to do what during Roman period were supplying Tunis. With this project, we intend to bring back the water where at that time there were the sources. This is vice versa, using sewage water of Tunis, of Sfax, and this is where we need mechanization. Because how to plan that one drop in a yellow context make a green context? How to plan really the new crop coverage? Which kind of technology? Can be irrigation, can be mechanization, can be introduced. Which kind of farmers we can bring over there? And we have to do, otherwise migration, we can still talking and talking and talking. I will stop just to say that on 99, where I saw some of your picture, 99, we were in Tripoli at the border with Syria, and we make Tecnolivo in campo. Fabio Ricci, you remember? Penso anche Mauro Pezzini. Tecnolivo in campo in Tripoli. We bring technology to let them understand how could be improved. And then later we did in Syria on 2005, up to 2006. Then on 2010, I will stop, sorry. The insecurity in the country was not anymore. Now we cannot go to do again olive production because the mine are making not possible and not is totally insecurity. But I went 3 times in the last 4 months. There will be really a large olive cropping plan for the whole Syria. And on 2004, we did some things with one of your colleagues that really I feel honored to remember, to celebrate. It has been really Gianluca Mondel, a person that introduced the research on olives in Syria on 2005. He make a map of the country where the water, vegetation water could be spread. He make a map of soil. And the map, when I went to Syria, I had the chance to enter again in February. This February 23, they show me, say, this is the work done by One Italia. And this was Gianluca Montel. This is why I like really to remember it. And thank you very much, and sorry for your voice long.
Only 2 words about Gianluca. You don't know, but Gianluca was an Italian researcher of Foggia University that has left us too early. And we every year remember his memory with a special prize for students, for PhD students. And yesterday there was the edition of this prize that is coordinated also by Alessandro. Alessandro.
Okay. Thank you very much, Biagio, for your very interesting teach. And now I invite to speak Pablo Caramasas with the last presentation. The title is The Challenges of Extra Virgin Olive Oil Production in New Regions, the Australian and California Experience. Please.
Thank you, Alessandro. Okay, thank you very much, everyone. And just a quick introduction of myself here. I'm an agricultural scientist, originally from Argentina. And I was asked by Professor Leone to just give you an overview of what we're doing in Australia and California. I work for a big company over there. It is right now the largest producer in the Southern Hemisphere. And the reason why Alessandro invited me is because obviously we apply some technology to the process. There's a fair bit of mechanization, and you're going to see a little bit of what we do right now. And so basically the idea is to sort of share what we do down there. And to start on that, first I need you to sort of understand the kind of challenges that we face. In the first place, in the Southern Hemisphere, we produce no more than 5% of the olive oil of the world. We understand that there's no way for us to compete with Europe in olive oil production, so we are forced to compete with Europe in terms of quality. And that, in a sense, means starting harvest early, because we all know, as Professor Ruggini mentioned, and Alessandro as well, that olive oil quality, best quality, comes from low maturity fruit picked in early harvests. So that means that our harvesting window is much earlier than what normally is in the North Hemisphere. And that brings along a lot of difficulties, technical difficulties to us. So again, we want to produce high quality oils. That's the only way for us to compete. There's another very good reason for doing that, which is if you start early and you finish the season early, that means that you will not be impacting negatively in the flower differentiation of the following year. So the typical annual bearing of the olive tree would be sort of moderate. So that's another good reason why we sort of start early picking fruit. But picking fruit early brings along a lot of difficulties. One of those is that we, by picking early, we just have to deal with fruit that is of low maturity. And fruit of low maturity is more difficult to pick, and it's more difficult to process as well. It's much easier to get the oil out from a ripe olive than it is from a fruit that is of low maturity, green fruit, basically. Also, in order for us to produce in an economical way down there, we certainly need to consider irrigation, and irrigation is a very important aspect of our production strategy. But also irrigation means high moisture fruit to process, and the number one enemy of olive oil making is moisture containing fruit. So we have to deal typically with fruit that is normally wetter or with more moisture than what typically is processed in Europe. At the same time, mechanical harvest is a must. There's simply no workforce down there to pick the total hectares that we have planted down there. We have 6,000 hectares. There's simply no people in Australia to pick that manually. So we simply were forced to develop mechanical technology to pick all this area. And mechanical picking also brings along different new challenges that I'm going to discuss with you. So all this is just to sort of put you in context of what all the problematics we have to face, and how we try to sort of adjust the new technology means. For instance, the ones that Alessandro studies, we are all the time looking at what he's doing here, sort of to adjust the new ideas from here to our needs down there. Australia has a very interesting weather condition. All the area of the south of the country has a typical Mediterranean weather, and this is easy for you to understand. Very cold winters, very hot summers, and rains in winter. Basically what happens here in this part of the world. So that allows for good olive production, cost-beneficial olive production. Our groves are in the state of Victoria, down in the south of the country, and the different areas of production, whether they are on the west of the country or on the east, they're pretty much, the challenges are more or less the same. One of the big problems that this country has is there's no water. So there's no water underground. So we only depend on rainwater and the water that the river brings from the north areas of the country that have more subtropical weather. In California, on the other hand, we have a totally different challenge. California, for those of us that love fruit production, is possibly heaven, because it has an incredible weather for fruit production. But at the same time, there are some challenges over there. The olive industry in that country has been developed, in my opinion, a bit too far north, and that means that some olive groves in the north area, north of Sacramento, which is the capital of the state, are exposed to frost, and that's a big problem. Going down south to the Imperial Valley, there's a lot of water, but we're stepping into areas that are already too hot. And as Professor Ruggini mentioned before, that has a consequence on the quality of the oils, particularly on the chemical quality of the oils. Oleic acid content is very low, total sterol content in the oils are also low. And then a few other issues happen in that area. So those are the areas of production in that country. And what is interesting is that in these two areas where we are located, we have almost 2,000 hectares in California, 6,000 in Australia. The planting conditions are totally different. Californians have adopted what we call the super high density groves. So basically plantations that are 4 meters in between rows and in between 1.5 and 1.25 meters in between trees. And that creates quite a fair bit of challenges. For instance, fruit size is a challenge because there's a lot of competition for light in the canopy. So then if you're a processor down there, up there, it means that you have to deal in the processing plant with fruit that is undersized and has a huge impact on oil recovery. In Australia, instead, plantations are more of what we call intense plantations, so 6x4, where there are no more than 450 trees per hectare, and the modality of picking and pruning in that country is totally different. We are going to discuss that now. But why irrigation? We are so dependent on irrigation. For us, processing olive oil in those areas, you have to consider that we have no kind of help or subsidies from our government, so we must be efficient both at farm level and processing plant level. Pretty much, we all target or try to target around 1,800 to 2,200 kilos of oil a hectare. Those that don't reach those levels are pretty much out of the business. So you have to get there. And this is a study done in Spain that, in my opinion, exemplifies that very, very well. These researchers, Redondo and other researchers from the same group, they basically decided to study oil quality based on irrigation stress, so basically stressing the trees in order to get more biophenols, polyphenols out in the oil. We know that polyphenols are desirable substances, part of those minor components of that super scent that Alessandro Leone was mentioning before, and they are antioxidant substances, and for that reason they are very, very important in the composition of the oil. So by stressing the trees, you can actually get oils with more polyphenols. So this is a study in the first column, a Picual variety, a Picual olive farm with 100% of a KC irrigation, so full irrigation. Everything that the tree needed was actually supplied. And then the two other columns show the same, another olive farm right next to it, same Picual, with only 50% of what the tree needed for growing, flowering, and oil accumulation. And they did achieve this increment in oil content. But what I want you to see here, which in my opinion is very important, is that also at the same time, by achieving higher polyphenol contents, they also had a negative impact on the total amount of oil produced on a per hectare basis. So irrigation plays a huge role on that, and managing irrigation is key. So for us, obviously, understanding that there's no water in our environments, we just have to look after that particular means of production. We obviously must be testing this on the trees all the time. Water trace index, which we measure by airplane, using cameras on airplanes. It could also be measured by satellite, but with satellites it takes more or less 2 weeks for us to get those images, while by airplane it is a bit more expensive, but we get the data right away. And this kind of analysis, doing with cameras, allow us to understand which areas of a farm are were being under irrigated, which areas of a farm may have problems with clogged drip pipes, lack of pressure inside the drip pipes, and also allows us to help understanding what's the best irrigation scheduling for the different areas, because obviously all the different areas of a farm have different soil types, and that has an impact on how much water is available for the trees. So irrigation equipment like stationary moisture probes, if you come to see our farms, you will see that they are located in different areas of a farm, so we are following all the time what's the available water content in the soil, and then based on that data, we are basically deciding what's the irrigation schedule to understand basically how the availability of water is trending in the soil at all times. So this is key. This is pretty much ABC in these areas. If you want to produce or reach those 2,000 kilos of oil a hectare, you must do this. Other ways of analyzing water stress is basically using the stem water potential test with a pressure chamber, or the TDR system with a time domain reflectometry. It's just simply all new technology that we use all the time. If you see our guys going down to the field, you will see that they're going with these pressure chambers to basically remove leaves, put the leaves on the chamber and apply negative pressure until the sealant water comes out, and measure pressures to understand whether we are irrigating properly or not. And obviously fertilization is another very important aspect of our production. In the case of the leaf analysis, we typically do our leaf analysis in the middle of summer, because in the middle of summer temperatures are so high that the tree is stable. There's no so much movement of these elements inside the tree. And we combine that information with soil analysis that are typically taken in winter time. So with this information, we sort of put together the fertilization program moving forward to make sure that we just simply provide everything to the trees to grow and produce flower and produce fruit. Obviously, this fertilization, the cheapest way for us to supply to the farm, to the trees, is through the drip type. So we use the irrigation system to do this, particularly the major elements like nitrogen, potassium and phosphorus. But we also do low volume spraying as well, particularly of minor elements. There's a key moment in the olive growing season, which is the pre-flowering, so the moment before the flower opens, when it is key to have boron and zinc supplied to the trees, so as to get a proper elongation of the flowers and a proper fruit set. So that's also done in using sprayers in the farm. Professor Leone also spoke about the importance of pruning, and I agree with him with his measurements or in the share of the cake on what's the importance in terms of costs, of total cost of production. Mechanical pruning is extremely important. So you can imagine that in 6,000 hectares of olive trees, we are forced to mechanical pruning. We typically do topping and hedging. Basically, we don't do it every year. But we also do manual intervention, simply because there's no way to properly train an olive tree by only doing mechanical pruning, simply because the olive tree has a tendency of sending branches towards the other row, and those branches have to go because obviously the harvesting machine picking fruit on a straddle way, they would break those branches, or the other way around, those branches would break the mechanical harvester. So this is key to us. We spend a lot of time studying the best way of understanding the best canopy for maximum light interception. This is just an example of what we try to do in our farms in Australia, particularly, where we try to get a shape that maximizes the amount of oil that is accumulating in the olives, both on the top canopy, part of the canopy, in the middle section, and the bottom part of it. Professor Ruggini explained really well and showed a slide where he clearly showed that the fruit that is on the top of the canopy typically accumulates more oil. You had to understand that oil accumulation is all about light exposure. More light you have, more oil accumulation you get. So trying to have the same oil accumulation evenly through all the canopy is key. So just to give you a quick understanding, in our type of grows, the tree spacing is the one that will limit your tree height. So 80% of the tree spacing, the spacing between the rows, 80% of that will have to be the maximum height so as not to shade the tree from the next row. Okay, so if I have 4 meters in between rows, I can allow the tree to grow up to 3.2 meters. Otherwise, if I allow the tree to grow more, then that will start shading the canopy, the lower part of the canopy of the next row. So we are all the time working on this. Pest control obviously is another big problem that we had to face. For instance, soft nose or fungal diseases on fruit are a key aspect in production, particularly in Australia. They tend to pose a lot of challenges for us because these kind of funguses impact negatively on the quality of the oil, and pest control and understanding the different stages of the diseases is important for chemical treatment. We also do index evaluation, particularly in the NDVI, which is a normalized difference vegetation index, which basically what it does is very simple. We do this by airplane as well with cameras. So a normal tree doing photosynthesis, what it does is it reflects near infrared light and absorbs infrared light. So that balance will give us an indication, will give us that index called NDVI, and then we'll be able to make decisions on whether which areas are less favored in terms of photosynthesis, and then try to understand why the tree is underperforming on that sense. Another thing that we are exposed to is frost, as I mentioned to you, particularly in California, north of the country. Frost are a big problem. Frost have a huge impact on both production and also quality. So we tend to have GPS located frost fans in the farm in order to minimize the negative impact of those frosts. And as I mentioned to you before, since light is so important to determine crop, we are all the time studying how much light the canopy of our trees intercept. So we use plant canopy analyzers that help us understanding really how much light goes through the canopy, which is also obviously also dependent on how many leaves or how much leaves material there is per square meter in the canopy. So we are all the time studying that. Professor Leone also mentioned the importance of canopy volume modeling. For us, that's key because that's how we estimate the year's crop. This is a very important part of the work we do in the farm too, trying to understand how much crop we are going to have. And a key aspect of this is understanding canopy volume, because that's what's going to give you an indication of really how much fruit you're going to get that year. Obviously, this model is then adjusted because then we go count flowers, then we count fruit to fine-tune the estimation that we make. But canopy volume is the first step. And we do this with droning. So this is obviously very important to us. Professor Leone also mentioned that the #1 cost in the whole production chain is harvesting. Harvesting is an area where we worked a lot. He mentioned that, this Colossus machine, this straddle machine that was developed in Argentina, now it's being built in Australia, is a very expensive machine, certainly not for a low to medium size farmer, but it certainly is a way to pick these large areas, these large farms. Right now, I don't know any other machine that can actually pick trees over 4 meters height. These are slow machines, but for you to have an idea, these harvesting machines pick around 60 trees per hour or one tree per minute. That's more or less the speed that they can actually get to. We use also Pellenc machines, which are towed machines, towed by a tractor. They're very effective. They're faster. They do 180 trees an hour, but they can only pick trees of 3.8 meters high. We also use the broad machine, the New Holland machine, which I believe is a great machine too, which is, is more adapted or well adapted to super high density growth. So you get to see this machine more often in California than in Australia. And then the new generation of straddle machines, we use Optimus, which is also one of these big machines that has a higher speed of picking and gets to more or less 4.2 meters height of picking. So this is the technology we apply. All these machines go with a GPS system for tracking purposes, because obviously we are all the time trying to understand how many trees are picked a day, so we understand really how many more days we have until the end of harvest, and so we can actually manage our resources, and these tracking systems are very, very important for us. So this is another part of the technology we put in practice in this. Now stepping into the processing plant technology, we use state-of-the-art equipment. We have Italian made equipment made by Amendiuni here in Puglia, and basically it's equipment that has all the latest technology. In this area, I believe we are very, very similar to what is used in Italy or in Spain. And one of the key aspects that we apply to the process is understanding fruit condition. So if you are going to do a proper industrial job, you must understand fruit. So you have to characterize fruit, and this is key. So you need to understand what the oil content of the fruit is, what the moisture content of the fruit is, what the maturity index of the fruit is, and what the median size of the fruit of one olive is, to understand whether we are dealing with undersized fruit or fruit properly grown. If you do a proper characterization of the fruit, you can predict what the industrial behavior of that fruit will be later in the process. So we spend a fair bit of time on that. For instance, in California, what explains our efficiencies is the fruit size. Why? Because super high density grows, these hedge rows of olive trees that I showed you before, there's a very high competition for light in those canopies, and fruit size tends to be small. So when we have low fruit of small size, what it results from that is high viscosity paste, and then it's difficult to get the oil out from the fruit. In Australia, where we don't have that problem, there's less competition for light in our trees, fruit fully developed, and the problem we have in that area is typically high moisture because of irrigation in the fruit, and then the industrial challenge in that country is high fruit moisture, while in California is fruit size. So, but understanding and measuring and characterizing fruit is key to be efficient at processing plant level. Professor Leone mentioned also that color sorter technology is being used. We are big users of this technology. As Professor Leone explained before, these machines basically have a lens that sends light in the infrared wavelength and also on the visible range of light. And if you preset the ranges of the fruit, these machines are able to spill out anything that is outside those predetermined ranges. So we remove fruit that has diseases, fruit that has frost damage, and that problematic mummified fruit. There's a big problem in mechanized groves. Mummified fruit is fruit that is not picked by the harvester machine. Professor Leone mentioned that a 90% efficiency is a very good efficiency, but it's not so easy to reach in some cases. But 90% efficiency means that you are leaving 10% of fruit behind on the trees. In certain varieties, that fruit never drops to the ground, stays on the canopy of a tree, mummifies, full of oil, so totally ferments, and then remains on the canopy and mixes with the new fruit from the following year. So then that has a huge impact on the quality of the oil, and removing those small percentages is very important. This is a test that we did in Argentina with variety Arbosana, which is one of the most difficult varieties from that point of view, because it has a very strong attachment force of the fruit to the stem, so it never drops to the ground. So whatever you don't pick remains there. So as you can see in this chart, as the mummified fruit percentage increased, the FFA, which is the acidity, free fatty acids of the oil, increased exponentially. So removing the fruit is key in order to get the highest quality of olive oil. So if you go to California, to our processing plants, or Australia, to our processing plants, or our neighbors' processing plants, you will see these machines set up in the receivable area of the processing plant. In terms of crusher or crushing, the crushing step, what we have implemented, and also this was an idea from Alessandro, what is rotating speed of a crusher is key. So the crusher rotates at 3,000 RPM more or less, but if you are able to modify that rotating speed to speed slower or faster, you can have an impact also on the paste preparation stage of a process. This is just a study done in Australia last year, where we wanted to know, well, I have this arbequina that is starting to ripen, so it's not an arbequina that is green, it's sort of like a turning color, so the fruit, the texture of the fruit is not firm anymore. What rotating speed needs? So we are all the time doing this. We do a study at 2,700 RPM or 2,400 RPM, 3,000, 3,600 RPM, and then based on the results, we make a decision on setting up all the other processing lines. In this case, the results at the lower rotating speed, so 2,400 RPM, gave us the highest industrial efficiency in the process. Processing aids are also used heavily in these countries. This is an interesting area because this is not really much used in Italy. The only allowed processing aid used in the European community is talc, but if you go to Australia, California, Argentina, also enzymes, pectinase enzymes are allowed for use for olive oil making, so we heavily use these products. Talc powder is extremely important when you have to deal with high moisture fruit because it's an emulsion breaker. So when the fruit comes wet, talcum powder will help you getting the oil out. We use enzymes when the fruit comes green because when the fruit is of low maturity, pectin content in the pulp is very, very high. You need to degrade that to get the oil out. So processing aids are extremely important, and we have a fair bit of experience on dealing with these kind of products. One big challenge that we have in the industry is trying to reduce malaxation time. Because malaxation, the longer the malaxation time, the lower the quality of the oil. At the same time, the longer the malaxation time, the more oil you typically get from the paste. But that has a huge negative impact on the quality of the oil. So we are all the time looking at technology that allows us to reduce malaxation time without compromising the oil yields that we get from the paste. Enzymes are certainly one tool that helps us reduce the malaxation time. This is a study done with 60 minutes of malaxation time without enzymes, 60 minutes with enzymes, 90 without enzymes, and 120 minutes without enzymes. And if you see the efficiencies at the bottom, you'll see that not even malaxing at 120 minutes is able to beat the efficiency obtained with enzymes at 60 minutes. So this is certainly a tool that contributes to reducing malaxation time without having an impact on oil quality and efficiencies. We once came across a study done by Professoressa Antonella Tamburrino from the University of Bari many years ago, and she was proposing paste viscosity as a tool to understand or predict industrial behavior in olive paste, and we thought it was very interesting, so we decided to study it. And when we studied, what we found was that paste viscosity, when the fruit maturity is low, it is a very good measurement to predict industrial efficiencies. We found that there's a huge correlation, in this case negative correlation, between paste viscosity and industrial efficiency. Negative correlation means that when one parameter goes down, the other one goes up. So when you're dealing with green fruit, which is our case in more or less 70-80% of the whole season, in a low maturity context, paste viscosity, the lower the paste viscosity, the higher the efficiency of extraction that you can get by centrifugation. So we also measure this in our processes. The other technology that we have adopted, and in my opinion is very useful to reducing malaxation time, is heat exchange systems. Also, Professor Leone mentioned this. There are different types. We use the one called Heatex by Amenduni. But what I like of this technology is that it's very simple technology. You have to think of the fact that we are in Australia, we're at the very end of the world. So simplicity at industrial level is key, because if something breaks down, just flying an Italian technician or a Spanish technician over is not easy, not simple, and very expensive. So why I like this technology is because, as I said, it's very simple. These heat exchange systems are simply a cylinder with that has a hot water jacket system around to heat up the cylinder with an auger inside. So it is as simple as having a system, an auger that goes slowly, and a piston pump pumping against that auger inside and creating a positive pressure inside that pressures the paste and forces the oil out. So in 10 seconds, paste coming in, paste going out from the system, in 10 seconds that paste comes out almost already malaxed or mixed with most of the oil already out. So these systems also helped us reducing malaxation time. This is a study also done in Australia a few years ago, where we decided to say, well, okay, we're going to reduce malaxation time by 40 minutes, which is the first column, working with these heating systems against the normal way of working, so without the heating systems. And we found that by applying this process with a shorter malaxation time, we were able to get a higher efficiency than working the traditional way. So once we saw these results, we said, okay, we are going to adopt this for all the processing lines in our processing plants, both in Australia and California. And also, just to finish it off now, the other thing that for us has been interesting and we are looking into is sensors, ultrasound sensors to measure oil moisture in the oil. Remember that the maximum moisture content in extra virgin olive oil has to be 0.2%, no more than that. So this helps give us a good understanding whether the vertical centrifuge is doing a good job. And also we are looking into infrared equipment to measure free fatty acids of the oil. And this is also very important because not all the oil comes out of the same free fatty acids. So having an inline system to separate oils of different acidity is very important. And what we're doing finally, as we have implemented, and we believe is the way to work nowadays, is doing inline measurement of POMAS. So we are continuously measuring the oil losses in POMAS, just to ensure that we can sort of be proactive in adjusting the process so as to reduce malaxation oil losses in the waste. So anyway, this is just a quick overview of what we do. We try to give it a technological approach. In some cases, we have success. In other cases, we fail. But I thank you for your attention on this.
Thank you very much. Thank you very much, Pablo, for your excellent presentation and complete presentation about your topic. Now we can open the discussion, and if you want, you can make questions. Wow.
Where is he? Thank you very much. Very interesting for me because this is an area where I am not so competent. My question is, if 1 kilogram can be sold for $4, I do not understand that this is possible to get a good price for the oil, you see, because you need 7 kilograms for 1 kilogram oil, and if you multiply 4 by 7, the price is very high, which you must receive for the oil. So my question is, what about this balance? I cannot understand that this will work.
Okay. Yeah. It really comes down to, in my opinion, to local prices. So in Australia is an importing country. So it consumes 60,000 tons of olive oil, but produces only 17,000 tons. Italy produces 300,000 tons. So we're really, really small in context. But Australians are the largest consumers on a per capita basis outside the Mediterranean basin. So outside you and North Africans. So if you go outside the world, Australians are the ones that consume more olive oil on a per capita basis. So there's a very interesting market. We get a price for our oil if we factor what we sell with our own brand. We have the #1 brand in Australia in supermarkets. If we factor in the price that we get for that, and also what we export in bulk, we are more or less getting in euros around €7 a kilo. Producing 2,000 kilos of oil a hectare is actually a very good gross income. We have around a production cost of around 2,700 euro per hectare. So the economical equation for us work well. Per kilogram of oil, yes. We produce oil, yes. Yeah. Per oil, yes. Correct. Yeah.
We have a different market, I think now, or not, Pablo? We have a different market in the world because we have a European market, the USA market, the Australian market, and also inside the European market is different the price. Final price is different. More expensive Italian olive oil that now is around 10 euro in the gross market is around 10 euro per kilogram. Spain is less, but the olive oil is about the same. But made in Italy is made in Italy, I think, and
good point.
change the final price.
Good. That is
because
exactly
6-7 euro in Spain now.
In California, it's even higher the price of olive oil. That's the reason why we landed in America. It's just simply because olive oil price. I mean, America in volume consumes 200,000 tons of oil. But only produces 10,000 tons.
What do you think for the next harvest, the price in the world? Is the same, is less, is more? What do you think?
It will depend on what happens in Spain. That's basically what drives the price, international price. So, yeah.
Spain balance the price in all the world because produce more 50% of all production.
You know it very well.
Professor Giametta?
Sentite? Dunque, I refer something about the excellent paper of Professor Alessandro Leone, and particularly about the harvesting of the olives. I was a professor in Bari and also in Reggio Calabria, and I've studied very much the mechanization of harvesting of the olives. And the conclusion, I don't want to say many things about this problem. Because what said the Professor Leone is exact, correct. But the conclusion of this problem is that in Italy we have big trees, medium trees, and small trees. For the big trees, also we have in the last 3 years, 3, 4 years, 10 years, the problem of the bacterium of Xylella that are destroying many of these trees. Spectacular, not only for the fruits of it, but also because they are artistic, and it is a big problem. About the harvesting of these big trees, we can also use one type of mechanization, that is the shakers, big shakers, that can help the harvesting, that is because the cost of this harvesting is very high. For the medium, also the shakers, we can use medium, medium Italy, also South Italy, High Italy. For the little trees, we can adopt I think that we have to adopt the Spanish system, the continuous harvest. Because I stayed many times in Andalusia, and I have seen with my eyes that the problem of harvesting of this method, continuous things, are very fantastic for the quality and for the quantity. Because we can harvest about 5 times that we can harvest using the shakers. This is a continuous and there is, we can use the harvesters continuously that can use for the grape, adapt to this. Also the quality is very high, good quality, and for this now in the world, the Spanish is the first time, is the first country for the quantity and also the quality. Oh, about the problems that Professor Leone said, but the problem is really the high cost of these machines. But in Spanish, they use that the little farmers don't buy themselves.
Ma rent.
But they cooperative.
Yeah.
They use all the cooperative. They buy the machine and they use it in cooperative. So the costs are very high. We can use it. In conclusion, I think we are also far from using this continuous machine because we don't have. We have, but we don't have introduced this continuous thing.
Okay, Gennaro.
Okay.
Thank you for your comment. More than a question, was a comment due also to the big, huge experience of Gennaro Giametta that has studied oliviculture and mechanization of the harvesting in Bari and then in Reggio Calabria. Can you argue something about the comments of Gennaro, Alessandro?
Yes, I agree with Professor Giametta because the analysis is complete and I agree with your analysis. Today we have in front of the possibility to go in this way or in this another way. I think that the ways are two, and according also with Professor Ruggini, we can choose the street to the super high density, and we have the possibility to make a good olive growing, it's possible. And we have another street, medium density, with about 400 trees per hectare. And Pablo shows it's possible to manage a good business by using 400, not more 1,000 trees per hectare. Because the problem are the varieties, and Professor Ruggini know very well, I think that the problem when you use super high density, we check only 5, 6, 7 varieties and stop until today, or not. But if we use, for example, the medium density, 400 trees per hectare, we can use all other varieties. And Pablo shows it's possible to make a modern and efficient olive grow by using the same varieties, Coratina, Leccina, and all other varieties typical of the Italian genetic system. And I think that this is the future. Not only super high density, but I think that medium density is the best, is the best for the varieties and The problem is the mechanization of the harvest, but we have the solution also for this typology, not only by using the Colossus harvester that is much money to check this, but we can use also other possibility, and in same way we can economic, and we have a good future, in my opinion.
Thank you. I have two simple questions for Professor Ruggini. The type of grow, say for the same variety, can influence the oil quality? And the second question.
The time, I didn't understand.
Well, the grow.
The clone.
He talked about traditional intensive and super intensive grow. Can that influence the quality of the oil? That's the first question. And the second question, what you said in your presentation, excluding the mechanical harvesting, is it valid also for table olives?
Well, first of all, you can obtain the same oil quality with both kind of system of a training system. It depends also on the variety. Some variety produce a very good oil, other less. It depends. Some varieties produce high phenol contents, and the oil can maintain for more than 1 year, for example. And they produce, some other varieties produce some good flavor, tomato or artichoke or something like that. Also, this depends also on the year, because the same varieties can produce, according to the soil, to the environment, a different kind of, of flavor. Anyway, the density depends also, the oil depends also when you harvest. If you harvest, the olive are healthy, you can process also after more than 20 hours. Instead, if the fruits are not healthy, you should bring as soon as possible to the mills. Otherwise, you know, Leone said before. The second question, sorry, I didn't understand it because I can't hear today with my voice.
The second question regarded the table olive.
Yeah.
Table olives, the one that you eat. And I was asking whether what you said, of course, excluding the mechanical harvester, was valid also for the table oil. That's all.
L'oliva da mensa.
Yeah, the table oil, there is a specific table oil. In the past, people prefer olive oil, fruits with low oil content. Today, don't matter. Normally, we accept every kind of olive, but there are several cultivars. For example, Leccino is one of the best, or the other cultivar from Sicily, also from Apulia. Normally should be big fruits with little stones. And in the pasta should not be rich on fiber, should be morbid, another word. That's all.
Thank you.
Ok. Paolo. the president.
I have a question for Professor Leone. He mentioned that in Puglia region they wanted to reach the goal of zero waste, and for doing that they wanted to use the waste from the oil industry in order to produce biogas. But as you know, so biogas at the end produce digestate. So digestate anyway have to be managed. So how you think you will manage digestate?
This is the secret of my of my presentation. Yes, yes, because after the anaerobic processing, if is incoming 100 kilograms of the biomass, is outcoming 100 kilo, about 100 kilo of the water. It's like a simple water. It's very good for irrigation. It's very good for irrigation because the solids is very, very loose inside, and it's possible to make a good irrigation around the reactor, in the field around the reactor. And it's possible in this way to disposal the water in the field. Because you consider this, Professor, that to make the business in this with anaerobic digestion, during the 2 months of the milling, all the byproduct is storage in the silos. And after, during all the year, is used in feeding to the anaerobic digestion. And you have all 1 year to put in the soil the residual. And this is very good for irrigation. We have another experience, research experience with my department, with the colleagues of the agronomic part, and the results are very, very good. Different, compared to the results, that to use directly wastewater in the soil, the results are different, but by digestion, the results is very good.
I have a question for Pablo. Pablo, you mentioned you used the canopy volume for certain aspects of your production. Do you use canopy volume in the form of tree row volume for spraying, like we do in other fruit crops? Other fruit crops, like apples?
We only do olives.
No. But do you use the same process?
Same process, correct. It is the same plant analyzer, canopy analyzer. So what we have done is basically adopt.
Pablo, you can reach the floor, please. No, there. Okay. The mic.
Yes. But specifically for applying pesticides?
For applying pesticides, no.
And if not, why not?
Well, I cannot answer that. But what I can say is we have not developed this to tell me what's the most effective way to treat trees for pests and diseases. So all the canopy volume that we carry out, we mostly do it for understanding what the next year's crop will be. We're trying to get into see if the same technology by drone or airplane can give us enough detail to detect and quantify the presence of pests and diseases. But we have a long way to go on that front. So we have done a few steps on that front, but the truth is it's very difficult with right now with the technology we have, with the cameras we have on drones or airplanes, to be able to use that technology to determine, for instance, if black scale, which is one of the most important diseases we have in our groves, is in any specific stage, say eggs or instars or stuff like that. So, or larvae or stuff like that. So, I believe there's an opportunity on that, but we don't have experience on that front yet.
In particular, I was intrigued as to whether you use it for the volume of spray liquid and the
Oh, for sure.
volume of
Yes,
air.
sorry. Yes, yeah, for sure. So if you know what the canopy volume is on a per hectare basis, you know really how much liquid you need to reach all the areas. And yes, the answer is yes, we do use that. I thought you were referring specifically to the pest, but you were talking about the spraying. Yes, sorry, yes.
Okay, the last question. No question. So, not a question. Some communication. Now we have the guided tour to the Relevante, or the tour, if you want, you can also visit, because there are a lot of interesting machines there. And then we have to reach the bus. The bus, pay attention, that is a good news. The bus is not where I've left before, but is there at the exit agricoltura, that is along the husbandry there, particularly, few meters from here. Yes, 100 meters from here. So the building with the machine is there. You can follow if you want to see particular machines dedicated to oliviculture. Professor Leone, that is in his home, can also make us know better this kind of machine. But if you want, you have free time for the from now until 5 to 6. At 5 to 6 we have to be there to the bus, and at the exit agriculture, it's easy. Agriculture is along the husbandry. Okay, you see also on the map that you have. 5 to 6, this is the time. Okay, is there in front of this building. And there, from with the bus, we reach the center of Bari, when two tourist guides can make us enjoy the beauty of the Bari Vecchia. Vecchia is old Bari. That is a wonderful part of Bari. And then by feet we reach the restaurant where that is Al Sorso Preferito. You find it on the agenda, on the program. Al Sorso Preferito, where spaghetti all'assassina, killer spaghetti, are waiting for us. It's a particular dish, very, very complicated, yes. Menu, wow. Spaghetti all'assassina is a particular dish for us. So enjoy the fair. We see at 5 to 6 at the Agricoltura exit for the bus. Thank you.
Thank you all.